Hey friends, it's Timbot here at the TTL Makerspace, back with part 3 of Freecad for Lasers. Now in our last lesson, we modeled the sides of our little assembly. And along the way, we learned about tools like the external geometry tool and multi-body modeling using the subshape binder. Now we have perfectly aligned slots and tabs that we can actually produce on the laser. We're ready to produce the parts of our model, and we're going to use that using the Draft Workbench from Freecad. This will be the third workbench that we've covered, the first one being the part design, and then the sketcher. Now, the Draft Workbench is perfect for working with 2D shapes. As a result, it's going to allow us to create the vectors that we need for output to the laser. So let's jump into Freecad and get started. Okay, with Freecad open and our project loaded, we can see that we've got our bottom part and we've got our two sides. The first side we created by lining up the slots to the tabs using a shape binder that allows us to reference geometry from the bottom in our side. And then the second side we created very simply by cloning the first side, which copies all the properties and actually creates a dynamic link between them so that any changes that we make can be propagated through the entire model. I'm going to make use of that right now by opening up the spreadsheet and adjusting my material thickness. Let's have some fun with this. So we double click to open up the spreadsheet. Here's our material thickness. And just to prove that it is in fact working, let's go ahead and bump this up to like a thick material, like a 6mm here. We could be doing like full plywood, for example. So we'll bump that to 6mm, and when we go back, look at that, chunky sides, but everything still matches up perfectly. I'm going to go in the opposite direction. I'm going to go quite thin. I'm going to be using a thin balsa because I want to cut this out on the Ortur diode-based laser, which is awesome for surface etching. It doesn't quite have the cutting power that, say, the Omni CO2 one does, but our model here isn't going to mind. Let's just go to, I'm going to make this 1.5mm. There we go. And when we come back, we can see that it is in fact working here. Now, before we go too far, I want to point out to you this little navigation cube that we've got off to the right here. We haven't been making a ton of use of that, but it's a good time to familiarize ourselves. You've probably been using like the control right click to pan like this, the shift right click to rotate around like this, which is great for freehand work like this. But you'll notice that right up here on the navigation cube, if you click, it's going to give us very precise. It's going to give us a very precise view inside of our viewport here. You can also click the corners, and then that brings us back to our regular view. You've also got a little drop down here that allows you to change between your views like orthographic, perspective, isometric, and so forth. Keep that in mind because in a moment we are going to be bouncing into another workbench. So let me just bring this back to a viewport that I like, just like this. And so I'm going to go ahead and change my workbench. The workbench that we're looking for is called the Draft Workbench right here. Let's take a look around. Okay, so we immediately see this grid that is on the XY plane here. And that should serve as a visual reminder to you of what is going to happen. You see, the Draft Workbench is completely about working with 2D shapes. That's important because laser is going to accept basically a 2D format. We're going to take this 3D model that we've created and we're going to be transforming it into 2D shapes that are acceptable for use with the laser. There's a couple formats we could use. SVG is acceptable, DXF is acceptable, and you'll see as we go along that we've got quite a wide variety of options that we can export to using Freecad. The specific tool that we're going to be using is found under Modification, and it's right at the bottom here, and it's called the Shape 2D View. This is the one that we are going to be using. Now, I'm going to go ahead and use it right now, but you will see right away. I want to illustrate this because this can be very confusing when you first start working in the Draft Workbench. So I want to take my 3D model. So I'm going to hold Shift and I'm going to highlight all the parts that I want. And I'm going to go to Modification, Shape 2D View, just like this. And a very confusing thing is going to happen. You can kind of see right now that the look I've achieved is kind of strange. First off, you'll see that a Shape 2D View was created for each of the parts, and I do want that. But if I start hiding the 3D versions of these parts, you're going to see that what it's done is basically create something that would be quite unusable with the laser. Now, the very important thing to remember about the Draft Workbench's 2D shape feature is that it will always project what is in the viewport to the XY plane. So you have to make sure that you position your model in a way that you will get the projection that you want for producing your vector. Let's fix this up. We're going to make use of that viewport navigation cube. That's going to be quite handy now. So first thing I would like to do is let's get rid of this vector view that we don't want. So we're just going to delete that. We're going to bring back the visibility of our 3 parts. And let's say this time we go one by one. So I've got the bottom part highlighted right here. And in order to project the vector that I want onto the XY plane, which view should I be looking at? Now, I could try and get it just by, panning and, possibly rotating around. But I'm never going to get it, like no matter how careful I am, I'm never going to get it just right. So instead, we'll use our navigation cube. I'm going to click on the top, which gives us this kind of bird's eye view of the bottom piece of my assembly. If you want to confirm that for yourself, you can actually hide the 2 pieces that we're not working with right now, re-highlight the bottom. We'll go back to Modification. And now when we click the Shape 2D View, it'll look like not much has happened, but you can actually see there's a kind of a dark edge around here. And if we hide the bottom piece, there is an exact 2D duplicate of our 3D part. It's pretty good, right? Now you can still use all of your usual navigation stuff. So I can still rotate around like this, and I can rename the Shape 2D View. So let's do that, because if you're working with quite a few parts, it could get confusing. I'll rename it, and I'm going to call it Bottom Shape 2D. There we go. And let's do another one. Let's bring back one of our sides here. There it is. And now you can imagine that if you, click on the right-hand view, once again, we're going to be perfectly aligned to get the vector that we need. The bottom piece, is maybe the simplest one because we're just projecting it onto the XY plane and it's already on the XY plane. The important thing to notice here is that we're going to project this onto the XY plane. It's basically going to, rotate it 90 degrees. Let's do it. We're going to go Modification, Shape 2D View. And now let's hide that side piece. And it looks like it's disappeared, right? But if we go back to our view from above, you can see that our side piece is in fact there. Now, it's projected it onto the XY plane and it's overlapping our other piece. But if you highlight them one by one, you can see that they are in fact 2 completely separate vectors. If you find this view, like Like having them overlapping doesn't really affect our final output because we're going to export these shapes into another format for use in our laser software. But if you find it confusing to look at like this, there's nothing stopping you from highlighting one of them. I'm going to rename it first of all. So I'll call this my side shape 2D. There's nothing stopping me from taking my side here, going down to the placement property, looking for the position, and we can move it. And once again, you can see like our little navigation cube becomes helpful because we can see that the X direction is basically, you know, how we are aligned here. It also matches the red line that we see in the middle of the grid. And if we start increasing the X direction, we can move that on over. As I say, we don't have to, but visually it can be helpful working this way. All right, so that looks pretty good. And if we bring back our 3D model real quick here, we can see that we don't necessarily have to actually convert our other side into a shape 2D view, simply because it's the exact same as the one that we've created. So if we want to save ourselves a little step in this case, we can actually just export directly the two pieces that we have here and then duplicate it in the laser software that we're going to be using. So let's do that. I'm going to re-hide these. There we go. Because it's important that you highlight by holding Shift all the pieces that you want to export. And then you can simply go to File, Export, and you're going to have a ton of options inside of here. If you click the files of type, you can see I've already selected DXF, which is a very simple 2D format. But if you click that drop down, you can see like there are tons of options here. I'm using the Autodesk DXF 2D, but you could also, for example, use an SVG type of format. But let's go with the DXF. It's a very universal format. I think that's okay. And I'm going to give it the name that I want. So I'll call this, I'm going to call this my tab slot assembly, just like this. And I'll save it into my documents, just like that. And that's all we need to do. We'll have perfect vectors of our model, and we'll be able to bring them into other software, principally the laser control software. Okay, we're now moving over into the laser control software. Now here in the TTL Makerspace, we make a lot of use of a tool called Lightburn because it can be used for controlling lasers from this Ortur Laser Master that we're looking at here, all the way up to the more powerful Omni CO2 based laser. I have Lightburn launched. Lightburn is a combination of design software and laser control software, and it is laid out that way. This has been a great software to see appear because previously these two steps were always very divided and somewhat cumbersome to work with. Let's do a quick overview. Up top here, you're going to find all of your icons for various functions. Along the left, you're going to find your design tools. So basically the way it's laid out is that drawing tools are up top here. Just to illustrate really quickly, I can quickly draw a shape here, then I can select that shape, I can move it, I can scale it, and so forth. We won't be making use of the drawing tools in this video because we've created our design using Freecad. But I just wanted to point out that when I draw this shape, you can see that it is automatically informing the laser control software that we find over to the right here, where we see cuts and layers. Along the bottom of these tabs, you can see that I have options for moving, and this is actually for moving the laser head. I've got a console, and I can actually type in commands and send them directly, manually, to the laser from here. I can even create macros of commands to do sequences of things with the laser, such as moving it, and then maybe starting up its pilot to show where the laser head is positioned, things like that. There's a camera control tab, which has to do with if you have a camera attached to your laser. That's a fun thing we could look at. Variable text has to do with if you want to, let's say you're outputting like a series of serial numbers. You're doing like, product marking or something like that, and you want the SKU numbers to be incremented and output automatically. Variable text lets you do things like that if you need to make, like, say 1,000 SKU numbers. This is all part of laser control. We're primarily going to be looking at the cuts and layers options down here. Now, just below, you will find the laser controls, which are kind of laid out like a VCR here, where you can actually send your design to the laser using start, and it's going to be begin doing its cutting or its etching operation. We'll also make use of frame, which allows us to basically see how much of the bed is going to be taken up by the cutting operation that we're doing. And yeah, this is the very quick overview. We will get into that in more detail. Right down here at the very bottom, you can see that Lightburn actually has support for a variety of different lasers. I currently am working with the Ortur Laser Master, and so this is the only option that is showing here. But if I also want to work with the Omni laser in the TTL maker space, you'll be able to see that I can select that laser, and it remembers the properties of that laser. So you would see the bed size change. You would also see this little point right here, which is the home location on the Ortur Laser Master, is in the bottom left, but on the Omni would be in the top right, and it will remember things like that, and basically lay out the bed for us with dimensions specific to the laser that we want to work on. Now, this is a very quick overview because this is not an in-depth tutorial on using Lightburn, but we can definitely do more videos on that. For now, what I want to show you is how we bring our design that we created in Freecad and output as a DXF into Lightburn and lay it out for creating on the laser. So first off, let me get rid of this little square that I've created. And I'm going to go up to File. I am going to say Import. I'll go to my Documents. And I need to bring in the file that I created, which is the tab slot assembly DXF. I will open that up and just look at that, guys. Perfect duplicates of the design that we made in Freecad. And I'm going to go ahead and bring them on down here to be close to the home position. And a really important thing to notice about this DXF that we've created is that these are separate, right? I can grab them individually and move them. And that's important. The reason why I'm able to do that is because back in Freecad, if you remember, these Shape 2D were unique objects, and they remain unique objects when they come in as vectors into Lightburn here. And if you'll recall, we said, well, we don't really need to make a second side because we can do that in our laser control software. And this is one of the advantages of having the design software and the laser control software being combined in one, the way that we do in Lightburn. I can grab this shape right here. And if you go to edit, you can see that Control D gives us an option to duplicate. And it's going to place the duplicate exactly on the shape that we have just created it from. So you'll just want to grab it and move it out of the way. Now, as we've been working here, you would notice that in the cuts and layers box over here, it has automatically put one line that has a few properties. It has a mode, which it has set to line. It's got a speed power setting and a toggle that allows us to either output or, if disabled, not output this. Now, where is it outputting it to? Well, it's going to output it to the laser. And the mode that it is automatically selecting for us here is set to line, because line is the setting for cutting out a shape. And looking at our design, the software has guessed basically that these are shapes we want to cut out, probably because they are fairly simple outlines. But there are other things we could do. If we wished, we could change it to a fill. And a fill is for doing a surface treatment. So instead of cutting out the shape, it would be basically burning it onto the surface of the material. A good example would be if for some reason we wanted to put these on leather and you know, create nice geometric shapes on top of a nice piece of leather. A fill would allow us to do that. You've also got a sort of a mix of these things with fill and line. Offset fill we won't get into too much in this video. In fact, we aren't going to really be making use of fills at all in this one. So let's go back to our cutting option here. But if for some chance we did want to treat one of these shapes differently, there's a way that we can do it. And this brings our attention to the multiple colored boxes down here at the bottom. You see, lasers use a color coding system to determine what to do with a vector line. So let me illustrate that. Let's say I select this particular side and I change its color, which is currently set to, as you can see, 0, 0. 0, 0 matches up with black. This is important. A lot of people have difficulty distinguishing certain colors, so keep an eye on the numbers that are matched with the color. But I'm going to change it to this vibrant blue here. And as soon as I do, you'll notice that there's now another layer. And the software has guessed, oh, maybe for this other cut that I'm doing, you know, I want to do a lighter cut. And so it has increased the speed that the laser head will be moving at, and has kept the power the same. Now we can edit that all we want. I could say, oh, you know what, that's way too fast. I'm going to bring this down to like a 5,000, for example, right? And so this is how we are able to do different things at one time. If I switch this back to black, you can see that this second layer that was created is automatically deleted, because now everything is black and they all have the same speed and power settings. You know what this means? This means this is basically ready for outputting to the laser. Lightburn does an outstanding job of transforming the vector shapes that we've provided it into the G-code that's needed by the laser that we're connected to. So let's go into the software and learn a little bit about setting the speed and power settings we need to get clean cuts. Getting clean cuts on a laser is probably one of the more simple operations to start out with. This isn't to say there isn't a little bit of learning to do. But it is simpler than if you are trying to do surface treatments on a material. If you're doing something like engraving or etching, that's a little more difficult. In the case of a cut, we basically just need to have this laser burn its way through the material. And to do that, the two most important factors are the speed and the power. Now, coincidentally, on the right-hand side here of the software where we control our laser, you can see that the speed and power are grouped together. The speed is how fast the laser head is going to move over our material. That's going to be controlled by the stepper motors. The power is how strong of an output that the laser is going to use when it is firing. So our laser is basically going to be using our vectors here to determine the path. And so the speed that we set will basically be the speed at which it traces these outlines. And the power will be how much the intensity the laser is going to focus at. We are working with an Ortur, as we can see down here in the selections. That's the only one available to us. And the Ortur is a diode-based laser, which would have a good deal less total output in terms of wattage compared to, even a mid or lower power CO2-based laser. But that doesn't mean it isn't quite capable. Remember, we're only going through 1.5 millimeter balsa in this case. So what I would do is I would go in and I would set the speed that I want to use. I'm going to set it to 3000 right here. And I'm going to set my power up to 80. Now, how did I get these? Well, basically, I got these settings by simply running tests. And this is a very important thing I want to point out, is that you will not be able to find any kind of magical, universally applied settings for working with a laser. You can find some sites where you can sort of get a starting point for settings, but there are so many factors involved, and some of them simply cannot be fully accounted for. For example, the age of your laser, like how much the diode or the CO2 tube has been used. Over time, they degrade, and so you may find that over time, what worked well as 80, you might have to now bump it up to like 82, for example. Also, the materials you're working with. Well, you can't have a setting that is just for wood, for example, because wood has so many different types of properties that are basically impossible to fully chart. You have things like the density of the wood, the porousness of the wood, the fiber, the grain, the direction of the wood, whether you're cutting into an end grain or doing a cross cut. So as a result, what you're going to want to do is have a system for organizing your power and speed settings for what works well on your machine with the materials that you typically work with. Thankfully, there's something quite nice built into Lightburn, and I would encourage you to get used to using it. All the way at the bottom here, you can see there's a second tab called Library. And if I open that up, right now you can see I have the options to load or save a library. And there's a button called Create New from Layer. I'm going to use this to organize my settings for the Ortur laser, so that over time I can build up a nice library that works well for me. And then I'm going to actually take that library and put it on a USB key. And that way, this is really important if you're working in a community space, as I do, because there'll be lots of different people making use of the machines. You can't always guarantee that the settings you like are going to be present on the machine. So I am going to create a new library by saying Save As. I'll just store it into the documents for now, and I'm going to call this my Ortur library, just like that. And now that I am in my Ortur library, with the settings that I like highlighted, I'm going to say create new from layer. The material that I'm working with is balsa. And the thickness is 1.5 millimeter, which you'll remember matches what we assigned inside Freecad. And for the description, I'm going to call this cut. And I'll say OK. And you can see right now, I've just started my library of settings. I'm saying on the Ortur machine with balsa at 1.5 millimeters, these are good settings to cut, right? And you can see that I have some more options now. Now that I've got a setting stored in my library, I have an option saying assign to layer. So let's say I had another shape on here. I'll just quickly give myself a circle. And I'm going to color code it so that it's on its own layer here. And let's say I want to, cut this out from balsa. I can simply say assign to layer. And you see how it automatically adjusts the speed and power so that I don't have to remember every single setting that I used that was successful. And over time, you could build up a whole set of materials here. You could be working with balsa, different thicknesses of acrylic, etc., etc. And it's really nice that over time you can build up a library that works well with your particular brand of machine and with the materials that you commonly have access to. So I really wanted to pass along that tip because I notice a lot of people, marking this stuff down in a notebook and so forth, and that'll work, but it's also kind of error prone. All right, let's eliminate this. I don't really need these circles cut here, so I'm just gonna delete them out of here. I'll go back to my laser control tab right here, and we're prepared to send this to the Ortur with a speed of 3000 and a power of 82. The last thing that I'll point out is this option right here where you see pass count. In a lot of cases, especially with the diode-based laser that has less power, a single pass is not going to cut it. Even if you had the power set to the maximum and you brought the speed down quite a bit. First of all, I'll mention that you probably don't want to do that because if the head is moving very slowly and the power is at maximum, there's a good chance you're going to start a fire. The Ortur has a built-in smoke detector that will cut the machine off, and you'll have to do a reset if you're in danger of starting a fire. So generally, you want to keep the speed at something reasonable and the power away from the maximum. So instead of bumping up the power or bringing down the speed too much, what you can do is set it to do 2 passes. So it will actually repeat the cutting operation a second time, or even a third time or more if you wish. Now, it's worth pointing out that you can't just keep doing as many passes as you wish and cut through material. There is a point of diminishing returns simply because the focal distance of the laser, there's a maximum focal distance. And once you've cut down to that maximum focal distance, additional passes really aren't going to do anything other than charring the edges of your material or creating nasty melting around the edges of your material. So I'm going to cap this at 3, and I think we are ready to hit the start and send it off to the laser. And that's all there is to it. Let's send this to the laser and watch it make our parts. Now you're going to want to put on your funky laser glasses for this next bit. Safety first. Now, if you make it all the way to actually producing your parts and you find that they still fit a bit tightly, there can be a few reasons for this. For example, if you're working with acrylic, the laser could actually create a little bit of melting where it's doing the cuts, and this can cause the fit to be too tight. If you find that this is consistently the case, there is something that you can do. We'll create something called an offset factor back in Freecad that you can use to adjust the tolerance of your model. Let me show you how we do that. Okay, you've got the nightmare scenario here. You followed all the steps, you're super careful, and you find that after you produce your parts, your tabs and slots are still too tight a fit. And you don't know what to do about it. Well, the good news is there are things that you can do, and I'm going to show you one technique. We're going to create an offset factor, and even with this, we will benefit a lot from parametric modeling, as you will see. And we're only going to have to do it in one place because, as you remember, our other side here is a clone of the first side. So to get started, let's go back into our spreadsheet, and we're going to add in one more alias here, which I will simply call offset factor. Okay. Now I'm going to start off with an offset that would be much larger than we would ever use, but I'm just doing that because it'll make it a little bit easier to work with, and we'll be able to see what we're doing on our screen a little bit better. So I'm going to set this to 2 millimeters. And like before, we're going to go into the properties so that we can assign it an alias, which will be the offset factor, just like we did before. So that's offset factor, and the display unit is going to be millimeters. Click the OK. All right, let's see where we can make use of this. So the area we're concerned with here is in our side. We want to apply the offset factor to our slots that we've created. So if we open up the side, we can see that we still have the shape binder available to work with. So let's open up the padding here, and we're going to go into our sketch. Let's zoom in a little bit, and let's work with one of our slots first of all here. So I think probably the easiest way to illustrate this is we're just going to highlight this entire slot. We're just going to delete it so we can see how to apply an offset. Now, to work with the offset, we're going to be creating our external geometry to the shape binder, just like we did before. But if you remember, in order to apply external geometry to the shape binder, we have to hide this solid model that's in the background, or Freecad will get confused about what we're trying to select. That piece in the background is the bottom, so I'm just going to click on it once, hit the space bar to hide it, and now our shape binder becomes visible and selectable. So we'll take our external geometry tool, zoom in a little bit, and start selecting the corners. Here's one. Let's grab another one here. Might as well grab these. There we are. All right. So now we are once again ready to apply our box. So we'll click on that shape tool, and we're just going to draw it around like this. And maybe now you're starting to guess how we're going to apply this offset. I'm going to click on this corner and this corner of the shape binder. I'm going to use my constraint here, and we're going to go to the spreadsheet, bring up our offset factor, just like that, hit the OK, and it turns orange because we are using a formula. We do the same thing for the vertical. Go into our formulas, go to the spreadsheet, get the offset factor, hit the OK, right? And so now we've got a consistent offset factor, and because it's an alias in the spreadsheet, we'll be able to edit this. Obviously, we're not going to have a 2mm offset at play here. We'd have to have some significantly thick material for that to make any difference. But it does make it a little easier for us to work here. Let's do the same thing in the other corner. So no big mystery here. We're just going to go to the spreadsheet. Go to the offset factor. Apply it. Hit the OK. Pull this out of the way. Same thing for the vertical. And you can see it's already wanting to turn fully constrained. That's because our shape binder is fully constrained. The OK, hit the OK. And that's pretty much all there is to it. It's a simple trick, but it's a good one. If we go ahead and close out the sketch, you're going to see that we now have, you know, 2 differently shaped slots, but this is going to let us illustrate what we're doing here. If we go back to the spreadsheet, and let's say we bring this down to a more reasonable 1mm, even that's big. We go back to our model, you can see that it's, you know, a much smaller offset factor around our shape binder. And you can see that it's also reflected in the clone that we created over here. So that's looking pretty good. In reality, what you would probably want to do is dial this down to a very small offset, like a 0.02mm. And it looks like it's the same, but if we zoom in quite a bit, you can see that we actually do have still a tiny amount of offset between the two. And now you might have to output it to the laser a couple of times just to know that you're getting your proper fit. But this is basically how you could, you know, create an offset factor and still keep everything parametric and still have your model fully recompute when you change the value of that offset. You can also do things like a scale factor. There's all kinds of cool options that you can do using this technique. So that's all for our first 3-part series on Freecad for lasers. From us at the TTL Makerspace, we really hope that you've enjoyed this dive into free open source software and that you've been able to make something great.